a cranky day either. Okay. Homework for this week, right? Remember, homeworks are not programming. Questions, comments, different things to do on pencil and paper. Not really a program, okay? Homework this week is to build a flow chart. Okay? You went over flow charts on Wednesday. I'm going to do a quick review today because we're going to add one more element onto it. Okay? Control structures. Remember, in order to do something, how many are there? 3. Thank you. Okay. Number 1, I can go in sequence. Number 2, I can make a decision. And number 3, I can repeat. Okay. Ooh, wow. Spelling, not my thing. I think there's an A in repeat. There, okay. We can repeat. That's all we can do, okay? So you've got to be able to do whatever you need to do using one of these 3 things. The only way we can have control, okay? So, the only thing we can do in our flow chart is one of those 3 things, okay? Does anyone remember how we start? With a start. With a start. Right? The little like flattened circle, like pill looking thing. It looks like a capsule. We have lines going in the direction that we want to go, right? What was an input? Do you remember? Do you remember? Yeah. Input and output are parallelogram. Okay. What was the process? Rectangle. Rectangle. Okay. And that's pretty much what all we did last time, right? So going from one to the other, that's sequential. Okay. Does anyone know what it looks like on a flow chart if I want to make a decision or do a repeat? These actually have the same symbol. What symbol am I missing up here? Good job. A rhombus or a diamond. Okay. You're going to use that both for decisions and for repeating. Okay. So I go here. Right? I know you guys have maybe seen this. If yes, do A. If no, do B. Something that looks like that. Yeah? Okay. This is going to be your decision. If you're going to repeat, what you're going to have, I'm going to die on this thing. I know I say that like every class. It'll look something like that, and we'll get more into it, okay? But your repeats and your decisions are going to have that same shape in your flow chart, okay? In your homework, hand something in, please, okay? Do not get caught up in the equations and the numbers, okay? That's not what I'm checking. I'm checking flow chart, okay? I believe it says like take a salary and multiply it by like a percentage. Don't get caught up in the numbers. Do not get caught up in the equations. That's not what we're doing. It's not math, okay? Take it step by step with whatever it says and draw your pictures, okay? Remember, inside those figures, we're going to put notation that's going to help us understand what that was, right? So here, okay, start's always going to say start. Input, name. Okay, it'll say something like that, right? X equals 3 plus, I don't know, I'm just making stuff up, B. Right? Is X greater than 5? Okay. So you can see how I'm putting notation in those shapes to expand on what I already know. right? The shape is going to give me the action. What's in it is going to give me the info. Does that make sense? Yeah. Let me pull up homework. Just want to see what it says real quick. Because like I said, I'm afraid I don't want you guys to get caught up. Because I know this is something that a lot of people get caught up in. Oh. Hold on, I have to double factor authentication my thing. I get it. I'm a computer person, but it's still annoying. No, everybody thinks that. Okay, let me turn this back on real quick. And we're going to look at it. Oops, that's not what I wanted to do. Courses. Homework 2. Let's look at it as a student. Homework 2. Okay. I'm going to erase some of this. You may not be able to see it, but you'll be able to see it on yours, okay? So the first thing, allow the user to enter their hourly pay rate. What shape is that going to be? Parallelogram, right? You're allowing the user to enter something. Okay. Okay. Oh, that was my note. Allow the user to enter in the number of hours worked. What shape? Very good. Allow the user to enter in percentage of pay withheld. Okay. User to enter, user to enter, user to enter. Parallel, parallel, parallel. Yeah? Okay. Program will multiply hourly pay rate by the number of hours worked. Why?
Because it's the equation, the calculation.
Exactly. Program will multiply. You can stop there and draw my shape, right? Okay. Don't get caught up in the hourly pay rate by the number We don't care at this point, right? Okay. Program will multiply the gross pay by the withholding percentage.
Again.
Program will multiply. Yeah? Does that make sense? Again, we're not getting caught up. Withholding percentage times pay. I don't care. Right? Subtracts the withholding amount from the gross pay. Because we're doing an equation, we're subtracting. Make sense? Display the net pay after taxes. I think y'all are getting the word keyword display. Right? Just taking pictures. Okay. Hourly pay rate. Okay, so we've got rate. The number of hours. We've got hours. And the percentage withheld. So percentage. Okay. Those are our three inputs. Right? Okay. Yeah. Okay. I literally just took these sentences and kind of dissected them. That's all for these first three. Okay. Multiply. So this says gross pay. So they're in the thing. Multiply hourly pay rate. So that's the rate multiplied by the number of hours worked. Times the number of hours worked. Do I need to understand this math? to figure this out. Not necessarily, right? I am not an accounting person. Okay? Literally taking those sentences word by word and putting them where I need them. Okay? Program will multiply the gross pay multiplied by the withholding percentage. Okay? And that's going to be equal to the withholding amount. Again, do I need to understand anything about economics and accounting to figure that out? It literally told me in the equation. Okay? Subtract the withholding amount from the gross pay. Minus my withholding amount is equal to net. It's exactly what the sentence told me. Yeah? Make sense? Okay? Display net. Okay? I didn't get caught up in all those words with full taxes and money and pay and da, 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 da. I don't care. Okay? It's going to be your job as programmers to interpret from all different walks of life in order to automate it, right? That's all we're doing. We're automating processes, okay? This might be a programmer working in a financial firm, okay? Computers are everywhere, right? If you're a programmer working in the medical field, you need to have a medical degree. No. But they're sure going to shoot out at you. Find your way. You good? They're sure going to tell you, right? This dosage, this day, this drug, da 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 da, right? Do you need to understand fully and have a medical degree in order to program that? No. Okay? Break it down into the most basic steps. Does that make sense? So please, for this homework, all you have to do now is connect these and put the correct things in the shapes. We just did it. It took us, I'm gonna die on this thing. It took us what, like 2 minutes? Okay? Do not sit there and stare and say, well, I don't understand hourly rates and net pays. And I don't understand that stuff either. I'm not gonna lie. Okay? Does anyone truly understand American taxes? No. Okay? But I can read this sentence and I can automate it. That's all I'm being asked to do. Yeah? So do not get hung up in all of these words. Okay? It literally tells you the equation. Gross pay is the multiplication of the hourly pay rate with the number of hours worked. It tells me. Okay? You can tell this is not the first time I've used this assignment, correct? So I know what y'all are going to do. Trust me. Okay? Remember, hand in something. Questions about this homework, putting this flowchart together? We don't even have any decisions or anything going on here right now. Okay? Yeah? Okay. I don't know, it's one of these things. Okay. Everybody got their pictures and notes of this? Okay. Cool. So one thing, we've learned how to print, right? How are we going to take user input? Okay. So let's do this real quick. So user input. Okay. What did we use to output? What command did we use? Print F. Right? We use the brackets, the parentheses, the percentage number. Right? Okay. Command, format, variable. Right? That's what we did on lab 2, A, B, and C. Okay. Now, in order to take in It'll be very, very similar. Okay? We're gonna need a command, a format, and a variable. And our semicolon. I was like, we don't need that. Right? Okay, does that format look very familiar like this one? Yeah, we're not reinventing the wheel here, right? Okay. The command we use is scanf. Okay. So our command is scanf. And guess what we're going to put here? Format. Yep. Okay. Remember, D is going to give me a number. Yeah. We're going to put something here too. Now, this isn't done yet. Okay. Remember last week, what did I say a variable was?
First data.
It's a memory location, right? So when I declare a variable, what your computer does, it finds a chunk of memory big enough to hold an int, and it puts it aside and says, that's where I'm going to put it. Okay? When you print, you just say print whatever's in there. When you read and you want to put something in that location, we have to say, okay, that is a really crappy ampersand. Okay? Not too bad, is it? It looks more like a treble clef, doesn't it? I'm not sure what the difference, I mean, I know what the difference is, I'm not sure what that is. I mean, that's kind of what it looks like, right? Is that an ampersand? Yeah, they're pretty much similar, aren't they? Okay. Left turn, sorry, my bad. Okay. What that ampersand does, ampersand, what was it called? It's a little thing above the 7. Okay. What it does is it tells the program, I want to put whatever's here into the memory location of this variable. Okay? Does that make sense? When I execute this and the user puts in 3, it's going to put it in the memory location that it has allocated. Okay? So, step A, you can't compile. Check your scanf. Well, actually, number 1, check all your semicolons. Step 2, check your scanfs for that extra ampersand. Okay? If you want to put a prompt, you can do it in a couple different ways. Okay? Remember, multiple ways of doing something. The way that makes sense in my brain is you can do a printf, enter number. Yeah. Scanf. Like that. Okay. You can use your printfs to put your prompts. Because remember, is this going to give me a new line? Why? What's missing? Right? So it's going to print this on one line and then wait right here because there's no /n. Okay? The user is going to type something in, it's going to put it into that variable. Okay? That's how we get user input. Does that make sense? Right now, we're only going to be doing ints and doubles, which is kind of floats, which is what we did on the print from before. So we're just pretty much going to use the %Bs and Fs. Okay? Now, one thing, %F That's what you're going to use when you use a decimal. Okay. You can format that decimal. I know some of you guys were playing with the average last time about how you had like 5.3. Wasn't it something like that? It gave you like 8,000 at the end. Okay. You want to say, I want 2 decimal places. So say we're doing money, right? Money, we only need 2. For set F, you can put a number, dot, and a number. Okay. What that does is it tells the formatter, I want this many numbers, I want this many decimal points. Okay. Most of the time, we don't care how many are in front of the decimal. We care about how many are behind. Okay. So if I put a 0 there, it's just going to put whatever in front of it that we want. Okay. What we're going to be concerned with is what's after the decimal point, which kind of makes sense, right? I want 2. Okay. So you put that 0.2 to give me, to tell it, I only want 2. So this is going to give me 5.33. Okay. Does that make sense when we're doing output? Yeah. Okay. Questions about scan? We are going to use scan this week. Okay. Okay. Let's get back into our control structures. Okay. So we did an if and we did an else last time, right? Those were selection. If the sky is blue, we can go to the beach. Okay. Else, it's gray and we want to stay home. Okay. Decision. Now, what if I want to repeat? Okay. There are 3 ways to repeat. So the first way to repeat, I'll put it over here. I know my number of times I want to do it. Okay. I want to do this 4 times. I want to do this 6 times. I want to do this 8 times. Does that make sense? I know how many times I want to do it. Okay. The other one is going to check before process. I'm going to say processing. And then the third one is to process, then check. Okay. And when I say processing, I just mean doing whatever it needs to do. Okay. Whatever steps it needs to do. Okay. So either know how many times I need to do it, I can check before I do something, or I can do something first and then check. You see the 3 different on that? Okay. Do we know how many times we're going to do it? Do we know what kind of loop we're going to use? Anybody? Anybody? Okay. It's going to be a for loop. Has anyone heard that one? Okay. What about check before processing? Anyone have an idea? That's going to be a while. Okay. And what do you think the third one is? Do while. Okay. And those are our keywords. Those are our commands. Those are the 3 that we're going to use. Make sense? Okay. So when I say something, we're going to do the for first. When I say that we know how many times we're going to do it, let me use that with a grain of salt. Okay. Do I need to know at the very beginning of the program how many times to do it? No. But I do know eventually. Okay. Most of the time, you can use any one of those 3 interchangeably. Okay. It's what you're comfortable with. And it has to do with speed, but we're not dealing with that now. We're going to deal with that in another class. Okay. So for this class, those 3, we can make them interchangeable. Okay. I believe there's 2 labs, A and B. I believe A is using a for, and B is going to use a, I believe, if I remember correctly, A uses a for, B is gonna have you write the same program using a while and then a do while, okay? You can do the same thing, okay? Let's do some structure. 4 parentheses, okay? Now, when I'm doing a repeat, I'm going to be doing another block of code. You guys remember what the block of code was? Do you remember what symbol I used? The curly. Remember we used the block for the main? Okay. So I'm going to put open and close curly brackets in whatever I want it to be repeated. Okay. It's going to be the way of us telling the computer these are associated to that for. Okay. Sometimes it may be a single statement. Sometimes it might be 4 different statements. Okay. Doesn't matter. We're going to put the curly brackets. Okay. So a 4 has 3 different parts to it. Okay. Any guesses? Start, stop, and then increment or decrement. Do you guys know what those words mean? Increment, decrement. Increment means to add something to it. Decrement means to subtract something from it. Okay? And between them, we're going to have our lovely friend, the semicolon. Okay? There is no semicolon out here. Okay, just like that if. Remember on the if, it's like if the check and then there was no semicolon and the semicolon was after the statement. Same thing. Okay? So, where I want to start, where I want to stop, and what I want to do with it. Okay? What we call that variable that we put in here is a counter. Okay? All it's doing is it's sitting there and counting how many times I'm doing it. It's a counter variable. This is called counter controlled. Make sense? Counter controlled. Okay? Most of the times your variables for these counters are throwaway variables. And by that I mean ends I, ends counter. Something that really doesn't matter. Okay? Because we're just using it to keep track how many times I'm doing this process and executing this code. Does that make sense? Yeah? Okay. So if I declare int I at the top and I come into my for loop. Okay? So let's say I want to do something from 0 to 5. I want to print the number. Okay? That's just going to be my statement here. We're going to do that in 3 different ways. Okay? So where am I starting? What number am I starting at?
0.
0. I equals 0. That's where I want to start. Okay? Where am I stopping? 5. Okay? In these for loops, our stops, that's when you're going to use those greater than, equal than, less than. Okay? So while I is greater than, or I'm sorry, less than, right? Or equal to 5, right? Because I want it less because I'm going from 0 to 5, right? So as long as I is less than or equal to 5, I'm going to keep going, right? As soon as it equals 5, it's going to stop, okay? I'm going to print the number. Where does that one go? In the block, right? Oh, you know what? What is the number here? It's I, right? Couple things. Increment or decrement, what am I going to do? Add what?
This one.
This one. Okay. I equals I plus 1. Make sense? Okay? Start, stop, increment, decrement. Okay? Look good? Couple things to note. That was done on purpose. That right there, that tab. Okay? It is going to make your code more readable because you're going to be able to visually line up where that 4 is. Okay? And if you look at some of the examples, or if you go on the internet and look at some C examples, you'll see things are lined up with tabs and with spacing. Because remember, the code doesn't care about white space. It ignores it. So it's fast. Okay? If I had a 4 here that was executing about 40 lines of code, would I be very easily able to look at it and know exactly where it stops? Not unless it's tabbed in, right? When you read a book, right? Or you read the Bible, there's a reason why those indents are in there, right? It brings your eye to the next chapter, section, whatever, right? Make sense? Okay? Does everyone understand this? Yeah? Yes, sir. You're just stretching, rock it out. Okay. Now, when I do this increment or decrement, okay, I can do anything I want. Okay? If I want to print the odd numbers only, ooh, where can I start? What's the first odd number? Right? I can start it wherever I want. Okay? I is less than, I'll do it this way, because that's how you're going to type it. That's just how I wrote it, okay? Okay. And keep it I less than or equal to 5. How would I get the next odd number?
I equals I plus 2.
Perfecto. Okay? This increment and decrement can do whatever I want. Okay? If I want to go from 0 to 100, that's not, okay, by 5s. Right? If I want to count by 5, I equals 0. I less than or equal to 100. I equals I plus 5. I don't care. Okay? It's not always a 1. Okay? I will tell you one thing though. This counter variable will always be an integer. Always, always, always. Okay? Because when I count, do I count 1, 1.25, 1.5? Not unless I'm counting something weird, right? Okay? If I count how many, steps it takes me to get from here to the cat, I count 1, 2, 3. I can't count a half. Okay? So this counter variable is always going to be an integer. Okay? Make sense? Okay? So, say I want to go from 100 and down to 0 by 10. Where do I start? Where am I starting at? 100. Okay. I have to be greater than or equal to 0, right? Because I'm stopping at 0. How am I going to get there? Okay. Make sense? Okay. Counter control. Okay. Questions, comments about counters before? Okay. So, erase that. I'll let you guys catch up on some of that. There is something special that we can do in programming if we're going to increment or decrement by 1. Okay? I will give you a hint. Programmers are lazy. That's why we're programmers. Okay, I'm just going to put that out there. If something seems too hard and to take too long, what do? We write a program to make it easier. Right? Like in reality, we're lazy. Okay? So, writing I equals I plus 1, apparently with too many keystrokes for somebody. Okay? So, and it only works with one. What we can do, that is equivalent to saying I plus plus. Has anyone ever seen that? Okay. All that's doing is adding one. Okay. You want to guess how we subtract one? Minus minus. Okay. It's like 2 less keystrokes. Okay. Remember last week, what was the first thing I kind of told you guys? There are 8,000 ways to write a program. And none of them are 100% correct or 100% perfect, right? If you want to do it this way in your lab, I don't care. If you want to try that way, I don't care. Just make sure it counts down. That's all. Okay? Remember, there's not a 100% correct way to do it. Make sense? Okay. Any other questions on 4? What we do in the, I erased them already, in those brackets in that block of code is anything we've already done before. Okay? You can add, you can subtract, you can do a process, you can print, you can do a scanf. Okay? If you want a user to enter in 5 numbers, you can do a for loop and a scanf. Enter number 1, enter number 2, enter number 3. Okay? Anything we've done so far, you can do inside your for. As long as we stick to our 3 rules, right? If I put anything in a for, I'm in a repeat and I put my sequential in my repeat. We're good. Yeah? I can put a decision inside a repeat. Okay? We talked about doing odd numbers right here. That is my Jennifer you're talking to on alarm. It really is. That means it's like almost 9. I'm just saying. I gotta keep myself on track. Okay? Could I, and the answer is yes. Could I say for I equals 0, I is less than or equal to 5, I plus, I'm gonna use the plus plus this time. Okay? If I, and I'm just gonna do it like this because I'm lazy. Take that word from it. Y'all see that one? What did I do? What's that doing to me?
It's checking to see I.
So it's printing odds, right? What do we do here? Same thing. Is one right and one wrong? Is one correct and one incorrect? Negative. No, right? It is your personal preference at this point. Okay? As you learn and as you go. Make sense? These two do the exact same thing with a for loop. Exactly the same. Okay? This one does the odd counting in the for. This one does a decision and determine whether it's an odd and then prints. Same thing. Does that make sense? Okay. Does anybody think this way is easier? I kind of think this way is easier. Anyone think this way is easier? Y'all just don't even care?
It gets the job done.
I mean, honestly, yeah, if it gets the job done. But you know what? If I've not had coffee and I look at this, I'm going to go, what in the Hades did I do? I ain't gonna lie. You know what I mean? And again, this is going to come back to commenting. Okay? Both of these should have somewhere in it prints odd numbers from 0 to 5. Right? Then I don't even care what's in here. I know what it's doing. Right? Okay. Perfect example, though, of how there is no correct answer and there is no incorrect answer. Okay, make sense? Okay. Did y'all get all this? Anybody that wanted it? Yeah. Yeah, look, so wait, he's like, I'm just gonna take a picture. You good? All right. And by the way, the recordings of these lectures, when I remember, which is usually eventually before the next lecture, is in the course portal, asynchronous only on the left. If you click on that, the links to the YouTube videos should be there. Okay. So if you ever need to go back or like forward through to like see, and what you see is kind of like that's right here, the board. Okay. Whichever, FYI. Okay. So that was doing if we know how many times. Okay. If we don't know how many times, okay, let's do a check before we process. Okay. So we use what we call a while. Okay. And check this out. Those look familiar? Yeah. That's where my block goes, right? My block of code. While something is happening. Okay. While the sun is out, we're going to stay on the beach. Right? Again, no semicolon here. Your semicolon will be in here in your block, just like the if, just like the for. Okay? So, while. Let's go back to our 0 to 5. We're going to print our number. We're going to use int I as our number. Just because it's a lot less letters to write than the word number. No other reason. Okay? While what? What is
I is less than 5.
I is less than 5? Or equal to. Right? Because we want to include that. Okay? Again, how else can I write it? I is less than 6. Takes away the equal sign. Means the same thing, right? Gets me 0 to 5. Okay. While I is less than 5, print F. We're going to just print I. Do. Okay. What additional step do I need to do?
Third of that, no need to. I plus 1 each time we will.
Perfect. Okay. The biggest thing to remember when you're in a while or a do while, when you're in one of these processing ones, you've got to make sure that you change what you're checking. Okay. So if I forget to do this, okay, it's going to print. It's going to print. It's going to print. It's going to print. What's going to happen? Is it ever going to stop? No. Okay. It's called an infinite loop. Goes on for infinity. You will get these. Trust me. I've gotten them. I still do. Okay. And it'll just print. And it'll just start scrolling. And it'll just keep going. And then you go, oh crap, help. Okay. So make sure with the while and do while that you do something to whatever it is you're checking. Okay. Big thing to remember. Okay. Is this going to work the way it is between the int and this? Okay. We know why?
If you understand about you get to 5.
Ooh, what is I? Nothing. Very good. Remember, we said declare, initialize, and then use, right? We said that last week. Because remember, in that memory location, do we know what is there? No. There is no telling what is there. A tree might be there. Can I then compare to trees less than 5? No. Right? We forgot to initialize. Okay? Again, 2 ways to do this. After that, I can say I equals 0. Right? Declare, initialize, use. Okay? The thing with the for loop initializes it in the loop, in that start portion. Right? Where we said I equals 0, we gave it that initial value. Okay. Another way you can write this, you can actually say int I equals 0 all on one line. Okay. That does your declare and initialize all together. Again, correct, correct. Not more correct, less correct. Correct, correct. Okay, it's pretty black and white. Make sense? Okay. Either one of those will work. So remember, variables every single time. I don't care what kind of variable, I don't care what you're using it for. Declare, give it an initial value so you know what you're working with, and then you can use it. Okay. Got to do those three. Okay. So this, I said before, checks before the processing. So the processing here is these two steps, and that should be indented a little bit more. Okay, we're going to use those indents like we did on the 4 to make our eye know what's going on. Because remember, that's for the humans, not the computers. Okay. So comes in here, I is 0, print 0. I plus 1 is 1 less than or equal to 5, prints 1. Adds 1 makes it 2, is 2 less than 5, prints 2. And actually, I don't have a /n, but I'm going to pretend it's there. Okay. Adds 1 makes it 3. 4. Is I 5? Is it less than or equal to? Yes. Yeah. I make it 6. It comes back up here. Okay. Is 6 less than or equal to 5? No. Okay. Once we get that no, it doesn't do any of that code anymore. Okay. Now, we know when it hits 5, it goes to the next step. We know that in our brain, right? But technically what the computer does, it does that check again. It gets a false and it kicks out of that block of code. Does that make sense? Okay. So it checks before processing. As long as it's true, it processes. When it's false, it kicks out. Make sense? Okay. Any questions about the while? Okay. Now you just saw we also did the same thing with the 4, right? Same exact thing. Okay. Last one. I'm going to leave my eye up there. We're going to use it again. Now, I'm going to do, I'm not doing that. We'll leave those. Okay. What I'm going to do is I'm going to do process first, then check. Okay. So, in order to tell your computer you're going to do a process first, you're going to do a process first. Yeah? What do you think comes next? Curly brackets. Okay, you're going to do something, right? While, oops, not a T, while something, okay? What are we wanting to do? We're wanting to do our print F with I, right? Okay. What do I also have to do with my I? Same thing as before, okay? My block between these two does not change at all. It's identical between a while and a do while, okay? While what? I less than or equal to 5. Okay? This while is exactly the same as what I had up here before, right? But what's going to happen in your processor? It's going to come here. It's going to print something first. It's going to add 1, and it's going to be equal to 1 at this point, right? So here's my output. Here's my I. Okay? Then it's going to say, it's I less than or equal to 5. Yes. So it's going to come back up, print it out, print 1. It's going to add to it. It's going to make I2 is 2 less than 5. Do you see the difference? It's slightly different. This is going to do whatever's in the block before doing the comparison. Okay? The other one does the comparison first. Okay? 6 of one, half dozen of the other. We did the exact same thing 3 different ways. Okay? In the lab, I did specify for part A, use a for loop. And in part B, I did say use a while and a do while. But you're pretty much going to be doing the same thing for both. Okay? Why would you maybe want to use the do while instead of the while? Any ideas?
Enter the process and then check the result. See if you want to.
If you know you're going to do something before ever having to do a check. Okay? If there's a possibility that you may never have to do a set of code at all whatsoever. Okay, if there's a possibility that you may never have to do it, you're going to have to do a while first. Because you're going to have to check first. This, if you're always going to do it, you can do a do first. Okay? You guys ever seen those command line programs where it's like, enter positive numbers, enter like a -1 to stop? Okay? Do while. Okay? Always asks you for a number first, and then it does the check. Okay? So once it gets down here, if I say input a -1 to stop, while it's not equal to -1, well, it is, so it moves on to the next step. Okay? You're not going to say, while it's not -1, if your user hasn't given you input yet. Can you? Yeah. Okay? The only reason you would use do while instead of a while is that you want to do something first. Does that make sense? Yeah? Okay. Now what we did before, in all of these, you can mix and match your 3 structures in those curly brackets. Okay? I can have a do while with a for in it. I can have a do while with a while in it. I can have a do while with a do while in it. That's called nesting. Okay? Remember, we can only do 3 things, right? We go in a sequence, we make a decision, or we repeat. That's all we got. Okay? Everything in programming is based on these 3 items. Okay? So from here on out, we're going to be doing things like expanding on our data types and how to use these types, these fors and whiles and do whiles. But this is the basics. It's all you can do. Questions, comments, concerns? Okay. Do you guys feel comfortable with the homework, number 1? Yeah. And the lab? I believe lab A asks for a user input and then does a count from 0 to whatever the user put in or something to that effect, right? Okay. And then the other one is like a while and a do while, and I can't remember if you liked me what I asked you to do. Okay. Few things to remember. Your semicolon at the end of your statements. Okay. Remember your fors, your ifs, your do's, your whiles. If you do not have them, only the statements in your block have them. Yeah. Remember your scanf. You need your ampersand in front of your variable. Okay. Otherwise, it will complain. Okay. And remember with your variables, what are the 3 things we do? Declare. Hello. Why? Anybody? Anybody? Fits, what do we do? You declare it, then you have to what? I'm gonna beat Fitz with a stick. I'm gonna beat Fitz with a volleyball. How's that? Declare, initialize, use. Okay? Declare it, initialize, use. Okay? Those 3 things you're gonna have to know. These 3 things you're gonna have to know. Sequence, decision, repeat. Okay? It'll say iteration, it'll say, different things, but in essence, sequence, decision, repeat. And then again, declare, initialize, use, okay? That's gonna be important because we're gonna apply that one to more than just variables eventually. You're gonna do that 3-step process, declare, initialize, and use when you do functions, when you do methods, when you do classes, okay? When we keep moving up and up and up. You're gonna do those same 3 things over and over again. Okay? Remember, I will be in the lab today at 1. We're going to try to figure out our lives in the lab, make sure computers work. Thursday afternoon, Friday afternoon, we're going to do virtually. I'm going to update everything on the website today, okay, in our class portal under class information. Yeah? Questions, comments, concerns? Have a wonderful, wonderful Wednesday.